Hi, this is Jude Leonard from Department of Physics, St. Joseph's College of Arts and Science, Cuddalore. Today we are going to discuss about the defects of a crystal and its types. Before understanding defects, we have to know what are lattice points. A lattice is a space where an atom is placed. If the atoms are arranged in a systematic pattern, then we call it as a crystal. Just imagine the block of bricks arranged in a systematic way to get a perfect shape for a building. Likewise, if the atoms are placed in such a way to get a perfect structure, then we call it as a crystal. Any deviation from the systematic arrangement are called as defects. It means that there is an imperfection in their regular arrangement, that is geometrical arrangements. Just as missing one or two bricks in the block, we can't get the perfect shape. Likewise, the deviation of atoms from its place paves a way to form a defects. These defects are classified in terms of dimensional basis: 0-dimensional, 1-dimensional and 2-dimensional. These are the major classification of defects in the crystal. The classification are point, line and surface. These are categorized on the basis of their dimensional process. Point defect is a 0-dimensional defect. Line defect is 1-dimensional defect, and surface defect is 2-dimensional defect. In 0-dimensional defect, the point defect are further classified as vacancy, interstitial, substitutional, squatty and Frankel. The line defects are classified as edge and screw dislocation, and finally surface defects are classified as grain and twin boundary. Now let me discuss about 0-dimensional defects, that is point defects. In that point defects, the first one is interstitial defects. These defects are normally, that is atoms are normally occupied in an unoccupied site. Just see the diagram. On the left hand side of the diagram you can see the structure of a perfect crystal where the atoms are equally arranged in a systematic pattern. And now on the right hand side, the atom is placed in between the normal sites. So there is a disturbance in that arrangement of atoms. Probably it may be the impure atom. For example, consider that you are standing in a line for a prayer service in your school or in a college. When someone disturbs you and stands in between you can consider them as an interstitial atom. The second one is substitutional atom. As the name refers, the atoms are substituted by the impurity atom in that lattice site. As you see in the diagram, the original atoms are replaced by the impurity atom. We can call it as a substitutional impurity atoms. The next one is vacancy. As the name refers to you, it's easy for you to understand what is vacancy. A defect in which the atom is missing, the original atom is missing, it is called as vacancy. And the next one is Sjctnc defects. In this defect, both cations and anions leaves their original sites and moves away. And this results in the creation of a pair of vacancy defects. So as you see in the diagram, both positive and negative charges, cations and anions, leaves their space from their original position. So it creates a pair of vacancy defects as positive and negative. The next one is Frankel defect. As you see in the diagram, an atom or a positive ion cation leaves its original space and moves in an interstitial site. So it is shifts to a unoccupied position, and this particular defect is called as Frankel defect. Now we can discuss about one-dimensional defects, the edge and screw dislocations. In edge dislocation, the extra atoms are inserted in the plane of a crystal lattice. As you see in the diagram, there are 3 atoms gets disturbed in the lattice plane. As a result, the structure of the crystal gets distorted. And in the screw dislocation, the atoms are arranged in the helical pattern. That is, the disturbance occurs in the normal to the direction of the stress. The two-dimensional surface defects are classified as grain and twin boundaries. The grain boundaries, which accounts for small misfits relatively. As you can see in the diagram, the groups of atoms combines together and forms a boundary-like structure. They rearrange themselves. The orientation of the atoms are in a specific way such that they can create boundaries among themselves. This type of twin boundaries happens when the crystals on the either side of a plane are mirror images of each other, that is, similar to each other, and this boundary will be a single plane of atoms. The volume defects are three-dimensional defects. They are further classified as voids, cracks, and inclusions. Voids are the regions where there are number of atoms are missing from their lattice sites. In other words, we can say that large number of vacancies defects collectively called as voids. The second one is crack. These crack rises when the charged atom experiences electrostatic dissimilarities among themselves between these stacking layers. As a result, the crack appears on the lattice plane. And the final one is inclusion, and this happens when foreign particles or large precipitate particles occupies interstitial sites. I hope this video provides some information about the defects in crystalline solids. Thank you.